Okay, good afternoon. We are going to be solving cube root equations, and I'm going to go ahead and give you the steps to do. Number one, solving a cube equation. So we have the cube root of 5x minus 1 equals 4. And we know that we're dealing with a root, so what we're going to do is we're going to raise the left side to the third power, and we're going to raise the right side to the third power since we're dealing with a root, and in order for us to address the root, we have to raise it by the power that the root is. So in this case, it's 3. So we have 5x minus 1 equals 4 to the third power, which is 4 times 4 is 16. 16 times 4 is 64. We're going to solve for x, so we add 1 to both sides. So we have 5x equals 65. And then our last step is to divide by 5. And x is equal to 13. 65 divided by 5 is 13. Now, I've explained to you in the past that you want to check your answers. So I'm going to go ahead and check my answer. We have the third root, 5 times 13 minus 1 equals 4, and now we have a true statement. Okay, example 2. Okay, we're going to go ahead and do problem 2. Solving equations with rational exponents. What are the solutions of 3, and then you have x plus 1 raised to the 2/3 is equal to 12. So before we deal with the rational or the fraction exponent, we're going to divide by 3 on both sides. So we have x plus 1 raised to the 2/3 power is equal to 4. Now that we have 2/3 as an exponent, we're going to want to do away with that fraction exponent. So we're going to go ahead and raise it to the reciprocal. And if you raise the left side to the 3/2 power, then you have to raise the right side to the 3/2 power. So you have x plus 1 equals 4 raised to the 3/2 power. So you have 4 raised to the 3/2 power, and you get 8. Now that 2 is interesting. That 2, the fraction, means that it's a square root. And if you're dealing with a square root, you can either have a positive or negative answer. So it's kind of forcing us to use absolute value. So we have x plus 1 equals 8. X plus 1 equals negative 8. So x equals 7. And x equals negative 9. Now, that's part of the work. We just finished solving the equation, and we were able to get 7 and negative 9. Now we have to check. So I'm going to go ahead and move this up so you can see how to check. And you notice that the book, they substituted x with 7 on both situations, and they came out to the left and the right side the same. Now you can do this in the calculator. So you have 3 parentheses. In this case, x is going to be 7 plus 1. And you're going to raise that to the power 2/3. And just like we did before, we're going to use equals 12. And you notice that's a true statement. Then you have 3 times x, in this case it's negative 9, plus 1. and you're going to raise it to the 2/3 power. And you set this equal to 12. And you notice again it's going to be true. So both answers are correct. What is the solution to 3 times the cube root of x plus 1 raised to the 5th power plus 1 equals 97? So what I'm going to do is I want to do some algebra here, and I do want to isolate that expression. So what I'm going to do is I'm going to go ahead and divide by 3. Oh, no, I'm not going to do that first. I'm going to subtract 1 from both sides. So you have 3 times the cube root of x plus 1, and this is raised to the 5th power, equals 96. And you see how I subtracted 1? Now I'm going to go ahead and divide by 3. So you have the cube root of x plus 1 to the 5th power equals 96 divided by 3, which is 32. Now I'm going to rewrite the left side as having a fraction as an exponent. So you have x plus 1 raised to the power 5, because that's 5 right there. And then your root is 3, and that's going to equal 32. Now you notice that 3 is an odd number, so we don't have to worry about making sure that we use an absolute value. So we're going to raise the left side to the reciprocal of 5/3, which is 3 over 5. 5 times 3 is 15, 3 times 5 is 15, so you have x plus 1 equals, and I'm going to do this in the calculator, 32 raised to the power 3/5, and you get 8. You subtract 1 from both sides, so x equals 7. That's what we have here. The last thing to do is to check. So you have 3 times the cube root. I'm going to use parentheses. 7. Parentheses 7 plus 1, close parentheses raised to the 5th power. And then on the outside of the radical, I have plus 1 equals 97. And now I will check if this comes out to a true statement, and it does. Problem 4, we're going to solve this cube root equation by graphing. You can model the population of Corpus Christi, Texas, between the years 1970 and 2005 by the cube root function 75,000 times the cube root of x minus 1950, where x is the year. Using this model, in what year was a popular Corpus Christi? 250,000. So what I'm going to do is I'm going to graph this equation. So I'm going to write down 75,000, and then I'm going to type in the cube root, and we have x minus 1950. Now you're going to notice you're not going to see anything, so you're going to go to your menu, you're going to go to your window setting, and I'm going to start at -10, that's fine, and I'm going to go to what year? I'll say to 2020. 2020. And the Y max, I'm going to say, since I said 250,000, I'm going to say 500,000 as a population. Okay, so there's our cube root equation. Now I need to type in where we want to be at, 250,000. So I have 250,000. Enter. And you notice that the two lines do intersect, and that's what you have to find. So you go to Analyze Graph, Intersection. And so when will Corpus Christi reach a population of 250,000? It says here in 1987. So your answer is C. In the year 1987, the population in Corpus Christi was 250,000. The correct answer is C.